Hey, everybody, and welcome back to the Powder Innovation Podcast, where we break down the tech transforming skiing as we know it. I'm your host, Colton Berry, and also founder of Powder of Innovation, and today we're diving deep into something that could literally help save the future of skiing. It's called feldspar-enhanced snowmaking, and we'll get into it right now. Yes, you heard that right. Just before the intro, we're talking rocks today, but not just any rock. Feldspar is a tiny mineral particle that might be the secret to keeping ski resorts alive as winters warm up and climate change continues to affect the ski industry. But yeah, let's take it to the top from cloud to slope. I think it's important for us to establish like a baseline understanding of how snow is currently made so that we can better understand how this technology is potentially going to innovate the space, or at least open up the space for more innovators to come in and change the game. If you ever wonder how snow actually forms in the sky, it's a pretty simple process. You have a lot of water that's up in the clouds moving around, and then there's the process of ice nucleation. So that's where a small little particle, either water or something in the air, serves as a baseline template for other droplets of water to come in and freeze around it and continue to build up until that snowflake is formed. If it is just solely water in those clouds, this can potentially be an issue as water can actually remain as a liquid in clouds, sometimes down to like negative 37 degrees Celsius, until something finally triggers them to freeze. Luckily, that's not usually what happens. They're usually small little particles called ice nucleating particles. It can be anything from dust to soot, pollen, even bacteria that can create this ice nucleus to serve as a template for the rest of that water to come and start freezing and building out the snowflakes. And so yeah, once a water droplet touches one of these ice nucleating particles, ice crystals begin to grow, vapor condenses onto the ice, creating that intricate six-sided flakes that we all know and love. A couple of things of note here: temperature and humidity are probably the primary factors of determining how big or how small or what ultimate shape these snowflakes end up taking, with higher temperatures leading to bigger flakes, lower temperatures leading to smaller flakes. But I think the important takeaway here is that without these particles, snow wouldn't form until the air was really, really cold. So these INPs are really essential for snowfall. Now here's where this connects to snowmaking. At resorts, snow guns mimic this nature to some extent. They blast fine droplets of water into cold air using either fans or compressed air. So if the temperature is cold and dry enough, typically below a negative 2 degrees Celsius wet bulb, these droplets freeze before they hit the ground, creating artificial snow. And so I mentioned wet bulb. Really all that means is that that's the temperature at which this water, when exposed to ambient air, that it will then freeze. While this process works, it is still highly inefficient. In fact, only around 75% of the water actually turns to snow, and the rest either drifts off, melts, or never actually freezes or contributes to the snowpack in any kind. Second, this guzzles water and electricity. In Canada alone, making snow uses 42 million cubic meters of water and nearly 500,000 megawatt hours of energy per winter. And so as change warms winters and shrinks snow windows, resorts are really hitting a wall. There aren't cold enough nights, not enough water, and not enough efficiency. So what if we could bring back the magic of ice nucleating particles in a snow gun? That's what one team that I found over the weekend has been doing for the last decade, but are starting to make strides outside of a laboratory on an actual ski resort. And so that's where the Laboratori de la Neu in Catalonia, Spain is coming in. They're led by scientists at a materials science university in Barcelona and a snowmaking tech firm called Techno Alpin, where they're really just asking a simple question: can we replicate nature's snow process inside a snow gun? And it turns out a mineral called feldspar, one of the most common on Earth, is an exceptional ice nucleator and doesn't do any damage to the environment. So not only can it help replicate the natural snowmaking process, it actually can help water freeze at higher temperatures than industry standard snow guns. And so that all they have to do is add a tiny pinch of feldspar powder into all they have to do, add a tiny pinch of this feldspar powder into snowmaking water, and the result is pretty astonishing. I mean, there's snow that forms faster, snow that forms at slightly warmer temperatures, and it consumes a lot less energy and water that's currently needed by today's snow guns. So early field tests show around 30% lower energy use and up to 90% water to snow conversion compared to that 70 or 75% for traditional snow guns. And like I said, this is not a toxic chemical. Environmental concerns were something that this team really looked into. And so feldspar is actually just powdered rock that's safe and natural and already found in the atmosphere. So it's really a very natural process, which is always great to hear. And while this team has been conducting research for a while now, since before 2015, since 2022, the team's been testing this tech at 2 ski resorts in the Pyrenees. They've outfitted snow guns with mineral dosing systems, adding a soda can's worth of feldspar to treat thousands of liters of water. They've performed countless tests on slopes that are closed to the public, just to remove any bias, any natural snow, or any current snowmaking technology that's used elsewhere. And they've tested things like snow volume versus water used, the energy per cubic meter of snow, the snow quality and durability, and the environmental impact. And so far, the results are pretty promising. No system clogging, no pollution, just more snow with less. And so if these results can scale, this is obviously a global game changer. It can help resorts make snow in warmer weather, saving resources and helping them stay open longer. But before we kind of get into saying that this is going to revolutionize how we make snow, this is going to reverse the effects of climate change, this is a 100% solution to what resorts are currently facing, we have to zoom out and look at the bigger picture. Really, this technology won't stop climate change. While this technology is amazing and the research team is doing great work, they understand that this is probably not a fix-all solution. It's not going to magically be adopted by everybody in the ski industry, and that the solution itself isn't going to reverse the effects of climate change. It's really offering resorts that are struggling a lifeline to being more efficient when it comes to snowmaking, making snow at a little bit lower temperatures, but really they also ran into a few challenges that have made the idea of global adoption tricky. The first is the engineering integration problem that they've had. So ensuring that feldspar can be delivered through existing snowmaking equipment without clogging or causing wear is certainly an issue that they've thought of. The method itself still has its limitations. It still requires sub-freezing weather, and a challenge has been quantifying exactly how much warmer the addition of feldspar can allow these resorts to operate these new snow guns at. The results are showing like a couple of degrees difference, which is significant but not life-changing by any means. Material supply and consistency is another one, so sourcing the right type of feldspar, it's one very specific subset of feldspar that they've found works the best, and preparing it and being able to find it and prepare it in the right way has been non-trivial so far. And so they need to find a more repeatable and producible way of producing this consistently. There might also be some issues with scalability. This currently has been done in like a closed off testing center and then in a small area of a couple of resorts. So as this starts to get bigger and done on a larger scale, the team is really gonna have to watch out for unforeseen issues that might occur as a result of this technology scaling. Another challenge would be any regulatory hurdles. So even though feldspar is a naturally occurring substance, the team is gonna have to demonstrate that there won't be any negative environmental impacts. There won't be any impact to safety, things like that. There's going to be some regulation that they're going to need to overcome. And then finally, skier and operator acceptance. So, convincing the right stakeholders of the benefits of this technology is a task. Snowmaking crews need training on the new system, and skiers need to be made wary of the artificial methods that the project has come to use. All that said, I think there's tremendous potential here. There's so many ski towns around the entire world that rely on snow. The economic ripple effect of a lost season is massive. It means loss of jobs, loss of tourism. There are entire communities and their way of life are on the line. So feldspar snowmaking, again, it could buy time. And that's everything. It could offer, 5 to 10, maybe 20 years of more viable ski seasons if it can be widely adopted and if they can continue to improve upon this technology. But, this also sparks some more conversation. This is a very innovative solution, but are we being innovative enough? Or is this really just delaying the inevitable? Even if snowmaking gets better, it still uses tons of energy and water. So it needs to be part of a bigger strategy, cutting emissions, embracing renewables, and transforming mountain economies for the future ahead. Still, from an engineering and environmental standpoint, this is a very promising piece of snow technology that I've seen, and that I think that the ski industry has seen in a long time. So I'll close it with, next time you see a fresh dusting of snow on a resort run, think about the science behind it, and if that snow was made with a little help from feldspar, that's even better. But that's the podcast. Thanks for tuning in, and if you found this fascinating, share it with a friend, and don't forget to check out our blog post, Instagram videos breaking this down for even more visuals and links to research. You can find us on Instagram at Powder Innovation for behind-the-scenes snow science. And let us know what topic should we cover next. Until next time, stay curious, stay inspired, and keep innovating. Thanks.